Yeah. So we'll go back to the we'll go to this session like describing cluster operators. So operators are a new concept for the application deployment, where it's going to take the operational knowledge of the application. So if you take the operational knowledge of the application, like for example, so installing the application. So from the operational perspective, so first thing we would do is installing the application. Then we'll do something called fault recovery if the application is not working fine. So we'll do something like fault recovery. Then we'll be doing a regular backup of the application, the regular backups. Then we'll be doing like monitoring the application and the current state, so for any abnormalities. So monitoring. Then we will be doing that update process. So these are some of things, like you can do more than that, etc. So any typical application, if you see, normally it involves these phases. So we'll install, so we'll if the application is going into error state or it's corrupted due to some reason, we'll do some kind of a fault recovery, we'll do some kind of troubleshooting to see that application is back. So we regularly back up the application. So either we entirely back up the application, we can do the backup by backup the application data. The data is collected by the application, or data is stored by the application. And we need to monitor the application for the health status, whether the application is properly working or not. So currently we need to monitor that using some kind of monitoring tools. And we'll do the update process, like the application will update to the different versions and all this. So these are what we call operational knowledge, or can say operational things which we do. So if it is as the application gets more and more complex, so these things also get complex and handled by a different teams itself. So this not be handled by one particular individual. So different teams will be there to manage that for a very complex application. So there'll be monitoring team, there'll be backup teams to back up that application data. So we have different teams to handle that for a complex application. So these are some of the operational knowledge. And what they are now doing is we are deploying the application as a container. So what they thought is, why can't we take this operational knowledge to the next level? Like, why can't we do an automated way of doing these things? So when I install the when I have an operator, through the operator I do the installation. The operator will take care of fault recovery. The operator will do the regular backup of that application and monitoring and all these things. So this is where this operator comes into picture. So we'll do normal application deployment. So when you do something, when you do the application deployment through the operator, operator will take care of these things. So this is what we call a intelligent way of operation. You can say intelligent way of automation. Because in the Kubernetes itself, we have inbuilt automation mechanism. To some extent, like we already talk about self recovery, or can say self healing. So when it is going to automatically self heal itself, we have talked about the controller manager. So when the application goes down, it will take action. It will recreate that application, which is called a self healing process. That is there inside the Kubernetes by default. But here we are doing something like before the application goes down due to some reason or due to some fault in that. So the operator will take action before the application goes down. So it is going to manage it. So it is a next level of automation where it will do itself this thing. So when you deploy that application through the operator will take care of this operational functions. So automatically. So we can set that. So how regularly we have to back up, what is the level of fault recovery, how to take decision on monitoring. We can manually customize that to suit our need. But this is a generic way. It can do these things by itself. These are something called what a regular human operator do. That's why the name it's called operator. So here the deploy, update, manage application. So this is normally a human administrator who does this thing. And how to achieve these things? So how to create the operator? So creating the operator is mostly the scope of the developer, because his application, if it want to survive in the containerization world, so he has to deploy that application through the operator. So operator means, so if there is an operator, so we will go and fetch that operator from a location, and we will implement the application through the operator, so that the operator will take care of the regular functions, the normal operational function of that application. So how to do that? So how the developer will develop the operator is through the something called custom resource and custom resource definition. So for example, inside the Openshift or inside the Kubernetes, any resource you are deploying, say for example, I'm deploying a resource pod. So this pod will have a definition file. So this pod will have something called manifest file. So through that manifest file, you're able to deploy that resource. So that is what definition, and whatever resource you are creating out of that definition. So I have the definition. So I can create a pod with a specific name and specific image and all these things, which is specific to one pod. So I'm creating that resource out of that pod. So this is a native resource, so I don't have any problem with that. But when it comes to the operator, so we have to customize the things. So we have to define something, and out of that we have to create that resource. So after defining that resource, and out of that definition, you create that resource. And this is completely customized. So that's why we call this as custom resource definition. You are defining one resource, and once you define that resource, whatever the resource you are going to create out of that, that's called a custom resource. Resource coming out of that definition. So that's what a custom resource is. And typically the developers develop the operator through this custom resource and custom resource definition. As operational personals, we will be looking at that CRD and CR. So what are the how they have created it. So we are not going to write CR and CRDs. So it will not be the work of the administrators. It is the work of the developer to develop that CR. That will be the building block of the operator. So they will be going through that, so that we don't have the how to do that. It's not there in this thing, but we'll be creating that definition. So through that, you are creating the resource. And now, how to implement this? So we talked about the operator. How to implement the operator? So how to implement the operator in the Openshift or in the Kubernetes? So how to implement that? So what are the ways to implement it? First, we call that as operator framework. Framework in a sense, it involves creating the operator to removing the operator, like creating operator, then utilizing the operator, then finally removing that operator. So this phases, so starting from the life to death. So how the operators are built. So that is through a framework. So the framework it involves two different components. One component is called operator software development kit. So this is shortly we call operator SDK. So SDK provides a means to develop the operator. So this will be mostly useful for the developers. So what the developers will do, they will adopt the SDK, and the SDK provides a scaffold, provides a frame for the operator, frame for the developer. And developer will look what are the things they require and what are the things they don't require. So whatever they don't require, they remove out of that frame, and whatever things that they want to customize, they will customize in that SDK, and through that they will be creating the operator. So the software development kit provisions a way for the developer to develop the operator. So that is one. After the operator is developed, so we get the operator and we want to utilize that operator. So operator is like, you can say it is a software automated software manager. So how to utilize that operator? Operator can be utilized through something called OLM. So OLM is lifecycle manager. So any software, in even the system level, server level, any software if you want to install, first you should have a means to install it. So you should have a manager to take care of it. So the manager will, what it will do is, it will, through the manager you will install that software. Through the manager you will remove that software. So there should be a place to do that. So that's what this OLM is doing. So OLM will be, if you want to install any operator in the Kubernetes or the Openshift, you should have a OLM in the place. So through the OLM you will install the operator. If you don't have the OLM, you cannot install the operator, because the OLM, which is a component which takes care of the entire operator lifecycle, starting from this starting to until it is uninstalled. So installation to the uninstallation. So it will take care of all these things through the OLM. So OLM will be responsible for that. In the Openshift, the OLM comes pre-installed. Pre-installed stands by default the OLM is available in the Openshift. So through the OLM, we are going to manage the operators. So whatever the operators are created, so through the OLM, we'll be managing that operator, like installing, removing, or like that, or updating, so that kind of things. And next thing, so where I can find this operator. So we talked about the operator. So in which place I can get this operator? So we can get it from something called Operator Hub. So there are two places where you can get the operator. One place is Operator Hub, another place is Red Hat Marketplace. So there you get that operator hub. Okay. So one place we'll just go to that and we see the sample operator. So we can go to something called operatorhub.io. So there you can go and find. So here the place, like it's like a Play Store where you find a lot of applications. So here it's like a Play Store for the operator. So where you find a lot of operators. So here you can find different categories of operators, like starting from AI, you can have big data, like that. So for example, I go to the database. So you can find some database operators here. So since the operator is in the infant stage, like even though we are discussing about operator, will not be working in full-fledged way in operator, but later on in the future, maybe the application deployment will be completely through the operator. Now it is an infant stage. We are just seeing what is an operator is. Now we have 34 operators over here. So I can take here you can search for any operator. Here you can just go and search here. So for example, here you can see the operator for Postgres. So this is one sample operator. So this is a PostgreSQL operator. Once you want to install any operator, you need to check the operator capability. So here on the side you can find the capability level. So here you can find 5 different capabilities, like basic install. You can do these are the capabilities. Like with this operator, you can do the basic install. You can do the seamless upgrade. You can do the full lifecycle management. It can monitor itself and can, in autopilot way, it can do its function by itself. So these are the capabilities of this, and these are the generic terms. So what this capability actually means, you have to refer to the documentation of that operator. You have to go to this documentation over here. If you click this documentation, you take to this documentation page, and there you will find how this particular operator is working. So the developers of this operator, they're given the description about that operator, how it is working. So how, for example, if we say high availability, how the high availability is achieved. So they will provide you the a block diagram to see how this operator functions. So how it is storing the data and all these things. So they will just give you an overview of this operator, how it's working. So there you will find tutorials, architectures, configuration, because each operator differs. So if I use the Postgres, this operator is different from if I use MySQL operator. So that will function in a different way. And the MySQL itself, you have multiple MySQL operators, and one MySQL operator may be different from other. So because each people will develop their own, there will be community-based operator, or enterprise. Some organization may develop some operator, or operator may be provided by some certified authorities. So there are different ways the operator can be available. So there are different means. The same operator, the same kind of application may be available with a different from the different sources. So it is up to us to decide which operator use, depending on our use case. So we have to see how what is our requirement, and how the requirement is fulfilled, and how to know this is through the documentation of the operator. So here you can read about the operator. So the Postgres, so what are the functions it can do, so how it can work, and you can see the details about installation, the post installation details, and you can scroll down and you can see about how they have created this operator. You can see about the CRDs and all these things. So we have talked about the CRD, custom resource definition. So there are the CRDs through which they have created this operator. So all these details you can go through, and depending on your use case, you can install which operator will best suit your need. So you will install that operator. So once you install it, so for installing the operator, so installation we'll see in chapter number 8. So here we are not going to see the hands-on installation, so we will see in chapter number 8 about the operator, how to install the operator in the web console. Now we can see the options. So once you open any operator, you will find the top left side, right side, you can find install option. This option is just to install on the Kubernetes. Option is to gives you instruction how to install it on the Kubernetes. So in the Kubernetes, you will not have this OLM. So OLM is available in the actually in the Openshift, it's pre-installed, but in the Kubernetes not pre-installed. So first what you have to do is, if you are using the Kubernetes, you have to install the OLM. So through this URL you will be installing the OLM. After that you will install the operator, then you will verify the operator. This is in the Kubernetes, so you can using the kubectl command. This is a Kubernetes. In the Openshift we'll see how to install the operator in chapter number 8. So there we'll going to see through the web console how we will be installing the operator. Okay. So this is one place where you can find the operator. This the operator hub. Another place where you can find the operator is Red Hat Marketplace. So this is another place where you can find the operator. So what is the difference between finding operator and operator hub in the Red Hat Marketplace? The difference is the Red Hat Marketplace, whatever the operators you are finding, so that will be a certified operator. So that will be certified by Red Hat. So they will certify that operator. They will go through the vulnerabilities in that operator, and they will certify whether it is enterprise grade or not. And for certifying that, they are going to like charge for that. Like if you want, so since if you want to use that, you have to use it through the, like you have to pay for using that. So in the operator hub, you will find open source operator. In the Red Hat Marketplace, you will find the operator which is you need to pay for that to use that operator. So in the Red Hat Marketplace, you can search some operators here. The same operator we can look into the Red Hat Marketplace. So here you can find the different operators. So different categories are there. So we'll go to the database. So here you can find the same operator which is there here. So this Postgres operator, which is here, you can install it for free. But if you want to use this operator from here, so this is a certified enterprise ready operator. So you can go through the certification. You can see the certification standards. And if you want to purchase this, if you want to use this, you have to purchase this operator, and you can use this operator. So it runs on the Openshift version more than this. The delivery method is through the operator. So when you want to use this operator, you have to purchase it from the Red Hat Marketplace. So these are the two places. One place you can find it on the operator hub. You have different types of operator where you can get that operator from here. Another place is in the Red Hat Marketplace. So when you want to use it from the Red Hat Marketplace, you have to purchase that operator, not be free. So since they are certifying it and they are analyzing and producing the vulnerabilities and all these things, so they are going to charge you for using that operator. You can look at the pricings and all these things over here. So these are the two different places where you can find about the operator. And the next thing is about cluster operator. So whatever the operators which we have discussed, it is application, or you can say general operators. So there are some operators at the cluster level. So this chapter is actually about the cluster operator. So what I mean by cluster operators? The cluster operators are something which is the cluster components. The cluster level components are deployed as an operator itself. For example, at the cluster level, so we have something like API server. So we have discussed about that. This API server, which will be running as a containerized service. API server. Then we have scheduler. So we talked about etcd. Then we have talked about the DNS. So some components like these are the cluster level components, which requires a very high reliability, because if this component goes down, we may not properly access the cluster. So there is a high degree of reliability is required for this kind of components which run as a containerized service. And what they done is actually from starting from Openshift 4. Series 4.1, 4.2. Now we are going through the course through the 4.5 version. What they done is starting from the 4. Series. The operator, this components, the cluster level components, starting from like API server, networking, a lot of components are there. So not only this, so you have a lot of components, so authentication, which are essential network, essential cluster components. So without which we cannot able to properly access the cluster. For example, the authentication component is not working properly, so I cannot access the cluster even though cluster is running and fine, but that component is failed, I cannot get inside the cluster. So they have identified the critical cluster components and they have developed the operator for that component. So for example, if I have the API server, API server will not be installed as a direct application, it will be installed through the operator. There will be an operator component for the API server, and through that operator what this API server component is going to do, what this operator is going to do, that is going to take the care of the reliability function. It's going to take care of the API server and all these things. It will take care of that function so that this component is deployed in a reliable way. So even if the component fails, the operator will automatically restart that component or redeploys the component, or something goes wrong or something getting corrupted, the operator will we can say operator will restore it back. That component is getting degraded as when we are using it, it started degrading. The operator will a level of the degrade, it will going to restart or it's going to rebuild that application. It will take care of that functionality, because that will take care of that, because that's the main thing we are going for the operator. So this is what a cluster operator is. So the cluster operator, the core cluster components like the network component, storage component, authentication, monitoring. So a lot of core components are there. So that component itself is installed as an operator. So through the that application, normally previous versions there were no operators that were deployed as a direct application. Now for this components, the reason why we go for the operators to get the reliability, so that in case that component is going down, the operator will immediately take action and is going to restore it back, so that we need not do that troubleshooting manually by ourselves. So this operator will to some extent, so because major can say at the extreme end, it's not going to do the complete automation, but anyhow it is going to do some like 80 to 90% of automation it will do. So to some extent we have to do some manual work also there. But majorly our work will be reduced or it will be automated through the operator. So this so this is what a cluster operator is. So here just we are having an introduction about it, because the operator concept is a very detailed concept. So if you want, you can go to the references provided here to know more about the operator. Here we are just saying what is an operator is. So what is an operator and where you find this operator, how to develop this operator, so what are the options available. So we have seen that, and we have seen what is a cluster operator. So this component, later on I'll show you the operator components, how to be this operator. So this operator like this cluster level important components are deployed through the operator. So we have these major components, because these are the essential cluster level things which require high level of reliability, because if these components fail, I cannot able to access the cluster. So the idea behind it, when you install the OpenShift cluster, these components are installed through the operator. So we need not install this operator now. So this cluster level operators, we will not install it. So when you install the OpenShift cluster, as a part of installation, this operators will be installed. Through that operator, that particular components will be deployed in the cluster. So we will not installing this manually. But user level operators, which I talked about, finding it in the operator hub and marketplace, these operators we will be installing. We'll be installing depending on our requirement. We'll be installing this operator and utilizing this operator for our application. But the cluster level operators, we will not install it. So this will be a part of the cluster installation process. So once you do the installation, this operators will be automatically installed as a part of installation process. Then you get that operator application, that particular cluster level components through that operator, and that operator will take care of providing the reliable function for that particular components. So this is what the cluster operators are. So that we are done with this section. So following that, there is so any doubts for this?
No, so far okay.
Okay. And now we'll go to the quiz. So here the quiz is like you have to match the terminology. You have to match the terminology. So here the operator terminology is here. So I'll just do the two one. So like they given here the terms, you have to match it with the definition. So here is that operator terminology. You can say definition. You have to match it here. So I'll do the last two. Other things you can type, because at the back you have the solution. So here this one, like I'll do this one, a public web service where you can publish operator that are compatible with the OLM. So this is a operator hub, where you can publish the operators by yourself, open source place where you can publish it and somebody can utilize that operator from there. So this is the operator hub. And the next one, platform that allows access to the certified software package. So certified software things. So certified operators are available in the Maridat marketplace. So this is the solution for this one. So certified operators. So other things you can work around. But first, what you will do is just go through this topic to give a reading of this topic, then try to answer this question. So that you will be knowing how these things are working. So there is in case if you're not able to figure out the solution, you will see the solution at the back. So with that we come to the end of the first chapter. So here you have seen about so these 2 points we'll see in the first section. We have seen about the operator OLM. We have seen about what is operator hub for discovering the operators. So we completed the first session. So the here I have not done the section number 1. So we've done section 2 and 3. So this section I will do it at the end of the course. I'll be covering this section. Okay, so now we'll move on to the chapter number 2. Chapter number 2, we're going to see verifying the health of the cluster. So this is the chapter number 2. So objective of this chapter, describe Openshift installation method. So as you see, it is just a description. So we are going to see describe Openshift installation methods and verify the health of the newly installed cluster. So how to check the health. So health in a sense, the functionality or working nature of the cluster. So we are going to do that. To achieve this, we have 3 different sections. So the first section will see the installation methods. So installation options. What are the installation options we do have? The next section, it's about the commands like troubleshooting the Openshift cluster. So we are going to verify the cluster deployment, and we are going to see we are going to see some troubleshooting commands. So when you deploy the application, how to start with the troubleshooting. This is a basic one. So how to start with the troubleshooting. We are going to learn a lot of commands. So how to we'll see about how to log into the cluster, how to create projects, how to create applications. All these things we'll be doing in this section. And the last one, we are going to see about how to provision a dynamic storage. So there we'll understand what is the storage requirement for the application and how to provision a dynamic storage to the application. So these things we will understand there. So, but storage itself a very wide concept. So here at the introduction level, so we'll see one concept among them, that is how to provision the dynamic storage, because mostly the dynamic storage will be useful in the deployment. So there is other choices also like static storage. So, but we concentrate on the dynamic, because dynamic storage is more flexible when compared to the static storage. So we'll be concentrating on how to provision the dynamic storage to the application. So first we'll understand what is the requirement for storage, then we'll understand how to provision that to the dynamic storage. Even though we have different methods to provision it, we're going to understand only one method over here. That's an introduction. So we'll start with the first section. So describing the installation method. So before starting this, I'll clarify to you that this is installation is not hands-on. So as I told, installation have been moved to a different course, which is go through like DO280. So this is Openshift installation course. So this the course has been moved to this. So this is a 2 days course. There is no certification for this. This now just it's now it is just a installation, like it's only like you can, for the knowledge wise you can go for this course. Red Hat Openshift installation lab. So this is a separate course. There you will have the hands-on practice. There you will see how to install the Openshift cluster at the hands-on level. So you will have the lab. So within the lab you will see how to install the Openshift. So in our course we are not covering this installation in detail. So installation, we are going to see the methods. So what are the installation options we have, and that too at a very wide scale. Like we're not going even in that depth. We'll just understand what are the two major methods available for the Openshift installation, and what are the difference between that two major methods. Then we'll see something about deployment process. So how the cluster deployment process is going to happen, and then we'll see the customization options available. So these are the things we are going to cover here. So when it comes to the Openshift installation method, so we have two main installation methods. So one method is called full stack automation. So this is one method. Another method is called pre-existing infrastructure. So into this we have different methods, but this is the major methods available. So one method is full stack automation. Another method is pre-existing infrastructure. So what is the difference between full stack automation and the pre-existing infrastructure? The deployment, so now we can see the Openshift can be deployed in number of different ways. So Openshift can be installed on, if you look at this course, you can see the Openshift installation can be installed in a cloud provider. It can be installed in a virtualized environment. It can be installed without an infrastructure provider. So there are different options available over the installation the Openshift.
Abdul, just to check, is this a free course provided by Red Hat?
No, it's not free course. You have to purchase this.
There is nothing mentioned about the fee that is business. Okay.
No, it is not free. I have to purchase this only.
Okay, normally they mentioned the course fee, like the duration, something like that. They mentioned the course fee.
Yeah, maybe this is.
What's the code? What's the course code? 322. Okay.
This is DO280. Maybe I select the country. It may change here. It's showing different country. Now I can find the keys. 27,000 something. So yeah, I'll come back to this Openshift installation. So the two major methods available are one is full stack automation. So this is called installer provisioned infrastructure. So here the installer refers to the service provider. So the service provider may be a cloud service provider or a virtualization service provider. So now at the cloud level, three service providers are supported to install Openshift. One is AWS, other is GCP, and Azure. So both three of them you can install the Openshift on any one of their cloud. So this is one option. Another option, you can go for the virtualization service provider. Like virtualization, we have VMware can provide Openshift support, and other one is Red Hat itself. Red Hat have a separate product, Red Hat virtualization. So they can also, you can install that Openshift on the Red Hat VM, the Red Hat virtualized environment. So that is another service provider. So totally we have 5. So one is 3 on the cloud provider side and 2 on the virtualization. So in the full stack automation, so what you will do is you will approach the service provider. Like you approach, for example, if I'm using the cloud, if I want to install the Openshift on the AWS, I will approach the AWS. The AWS, I should have proper credentials and all these things. I will provide that information to that service provider, and they will get our input. So for example, how many worker nodes I want, how many master nodes I want. So they will get my input. So they'll provide you some kind of a binaries. So using that you can generate the input. So you want whatever input you want to provision. If you don't provide that input, it will deploy that cluster. So with the 3 masters and 2 worker nodes. So then you can expand the worker node later. So, but you can provide your input to the service provider. So like the initial size of the cluster, that's very minimal input you'll provide, like your authentication to the cluster. So your account details you'll provide. You will provide your user credentials, so your authentication information. Then you'll provide input how much what is the size of the cluster. So how many worker nodes you need. So you will provide that input to the cluster. So once you provide that, so they will get your input and they will provision you all this. They will provision you the cluster with the required number and all these things. So it's very easy to deploy that. And so here, so the master node. So one thing is in the master node as well as in the worker node, everything will be the RHEL core OS. So the OS installed on both the master as well as worker will be uniform. So throughout the cluster, so it will be uniform. So everything will be having a RHEL core OS. So, but there are a lot of details to it. I will provide you the link to know more about it. So if you want to learn more about installation, I will provide you the link. There you can go and find how to do that, because so we are not able to discuss more on installation because installation itself is a separate topic. So on the Openshift documentation page, you will find a lot of references to see how to do the installation on different platforms or different environments, because you can install the Openshift on data centers, you can install it on so there are a lot of ways a lot of methods are available to do the Openshift installation. So here on this documentation page, you will find how to do the installation. So on different cloud providers is different different environments like bare metal and different private cloud. So you can see that Openstack, RHP, this Red Hat virtualization, and vSphere. So you can see how you can do the installation on different things. You can refer to this documentation page. I'll provide the link for that. So there you can go and find. You can just take any one specific thing. For example, if you want to know how to install it on AWS, you can go to this documentation. There you'll find how to install it, what is the pre-requirement, what are the things you want to have before you start the installation. So there you can find the things. So if you are interested in any learning about any installation process, you can go to this and you can find the recommendation. If you want to perform that at the hands-on level, you can opt for that course. So where you will have still more detailed way to do the installation. Okay. So this is one method where you can find the installation. So another way to do the installation is through the pre-existing infrastructure. It's called user provision. There is a mistake here. User provision. User provision infrastructure. So as the name indicates, user provisioned. So here, what we are doing is user is providing the infrastructure. That means here we are not providing the infrastructure. The infrastructure is created once we provide the input. So in a uniform way. Here the infrastructure is already there. So maybe it is in cloud or maybe it is in the bare metal or wherever it is. So the infrastructure is already there. So on the pre-existing infrastructure, we are going and installing the Openshift. So here, here we have the option like pre-existing infrastructure. The infrastructure can be different. Like we can have different worker nodes with different configurations and different hardware specifications. And here the benefit of going for the pre-existing infrastructure is in the worker node, I can have either core OS or I can use a RHEL based OS. So that is a option that we don't have this choice in the full stack automation. The pre-existing infrastructure, we have this choice whether you can go for RHEL core OS or you can use RHEL OS more than the version 7.6. That is the one option. You have this in this installation. So this is the installation method. This is an overview way we are seeing. So this full stack automation pre-existing infrastructure. And comparison between the method is that so in the full stack automation, so the master node and worker node will have a uniform core OS, and in the pre-existing infrastructure, the master can have core OS mandatorily, but worker can have a choice, like it can have a core OS or it can have a RHEL 7.6. Then we'll come to something called describing the deployment process. So this is actually the last stage of installation. So we are going to understand what is this deployment process, how the cluster is starting for the first time. So we'll see, we call this as a bootstrapping process. So normally the bootstrapping process or bootstrapping of the nodes, or bootstrapping of a server or any mission involves some steps. So, but that bootstrapping process happens every time. So when you restart the server, but here the bootstrapping is for just for one time. So only when you start the cluster for the first time. So we are going to understand this process. So how this bootstrapping process is going to work. So first we will understand the requirement. So what is the minimum requirement of machines to install the Openshift cluster? So when I want to install the Openshift cluster, what are the machines are required? Minimum, at the minimum level. Maximum you can have more, but the minimum machines. So for example, if I take on bare metal, so if I want to install the Openshift on bare metal, what are the minimum machines required and what are the different functions of each machine? So you understand that. Then we'll go for understanding that bootstrapping process. So minimal requirement is that you should have 3 master nodes. So minimum you should have 3 master nodes. You cannot go with 1 master node. So in the core Kubernetes, in the open source Kubernetes, you can go with 1 master node. But here on the Openshift, if you want to install the Openshift, you should have 3 master nodes. 3 master nodes. So 3, you can say control plane or master machine, and at least you should have 2 compute machine, so or worker node. This is also optional. So without the worker node also we can do the installation, but I should have the 3 master machine and one temporary. You can see one temporary bootstrap machine. So Bootstrap machine, we'll understand what is the function of Bootstrap machine. So in this process of understanding the bootstrapping process. So this is the minimum machine requirement. So Bootstrap machine, and we should have a control plane. Then we should have a compute. So compute plane. So here the compute plane, you can have Core OS, or you can have RHEL starting from more than 7.6. It is 7.72, 7.8. Like you can have this versions over here. And this is a RAM requirement and storage requirement of that machine. So what happens when the installation starts? So for the first time, so what the installer, the Openshift cluster installer, it will do. So when you go for the Openshift installation studies, there you will find something called Openshift installer. So as a user, so I'll be interacting with this Openshift installer. So installer is something like a binary package. So I'll be interacting with this Openshift installer. So what this installer it will do, so what it will do is it is going to load the resources. So load the resources required for the installation into a machine called Bootstrap machine. So the function itself, it's a temporary machine. So it's a Bootstrap, just for it's used for bootstrapping function. So Bootstrap machine. So what it will do is it will load all the remote resources. So remote resource in a sense, the binary packages, the softwares, the configuration files, setting files, all these things will be loaded into this Bootstrap machine. And what happens is the Bootstrap machine, first it will form the control plane. So first it will start the control plane. The control plane are the master nodes, so it will start the control plane. So the control plane will fetch the remote resources required to implement this on that node. It will fetch that resources from the Bootstrap machine. This control masters. So minimum we should have 3 masters. So we can have control plane 1. Then we can have control plane 2. Then we can have control plane 3. So this control planes will come up. So once the control plane is coming up, so what happens is then the etcd cluster. So normally we call that as worker node together. We call as etcd cluster because etcd is which is forming a cluster. So that will have the essential set cluster information. So it will start the worker node. The worker node will be started. So once the worker nodes are started, since it has to have a control node. So worker node requires a control node, and now only this control planes are coming up, right? So control plane is not fully functional now. So it is partially it's coming up, and the worker nodes are there. Now this control plane cannot control this worker node directly. So what happens is temporarily this control plane will be controlled by this Bootstrap machine. So this Bootstrap machine will temporarily control this control plane. So here the Bootstrap machine will act as a master for this worker node temporarily. It's not permanently. Temporarily it will act like, because the control plane is not up properly. So it is still coming up. So temporarily it will act as a control to this Bootstrap node. So finally it will inject all the resources, the software tools, the software packages, binaries, the containers to be up, then the configuration settings, all these things will be injected into the master node and the worker node from the Bootstrap machine, because Bootstrap machine will hold all the resources, which is essential for this cluster. So it will inject all the resources, and once everything is injected and everything is up and running, then this control plane, actual control plane, will take control of this worker node. So here it is going to be in a cluster format. So what it will do is this temporary control will be removed from here. So this temporary control will be removed. So and this control will be given to the actual control machine. So this temporary control will be removed from here. So actual control will be given to the control machine. So control machine will, like, it's not one machine is not going to control it, so it will be an entire thing. So it will, you can say this is like a cluster. So this will, control plane will now take care of this controlling the worker node. Okay. So now the control will be taken care by the worker node. And finally, this bootstrapping machine function is done. So it has created the control plane, it has deployed the worker node, and all the things are fine, running fine, and now the control plane takes control of this worker node. Now we have the cluster. Now this bootstrap machine is not required anymore, and what the installer will do is it will remove this bootstrap machine. So it will tear down this bootstrap machine. If you have done that manually, like if you are using the pre-existing infrastructure method, so you have to remove this machine from the things because it is not required anymore. And now we have the fully functional cluster. So this is what a bootstrapping process. So this is how this bootstrapping process is going to work. And so now we have the cluster. So this is a one-time process. Now for example, if I shut down all these machines and again I'm going to start it up, so in that case I don't require to do the bootstrapping again, because now it has all the resource and things are running on that. So now no need to have that this bootstrap machine again. This is just a one-time process during the first time you are starting the cluster. So this is the last stage in the installation. If you have learned about the installation, you will know what are the things going on. So this will be the last phase of that installation. So before that, there are a lot of phases and a lot of things are going on. So a lot of things will be loaded into the bootstrap machines. There you will learn about how this is happening. So this will be the last phase in the installation. So just we are understanding that last phase. So you can go through this steps. Whatever I discussed now, they are given that as a steps. So here they can see the steps, like they are given as 8 steps. You're starting from bootstrap machine boots, then it start hosting the remote resource required for the booting the control machines. Then you can go the step, and lastly, finally, you can see the installer tears down the bootstrap machine. So what are the points I've discussed? They are given as a summary of 8 points. So you can go through that points. So it's very simple. First, what happens is, I'll just repeat again. Here, the installer, the Openshift installer, will load all the machines on the bootstrap over here. It includes the remote resources, including the configuration files, the ignition files, the setting files, the software packages, binaries, and all these things are loaded into the bootstrap machine. Then the bootstrap machine starts the control plane. It will supply the remote resource required to that, so that it will install the packages and softwares all over there. Then temporarily the bootstrap machine will control the worker node. Worker nodes are coming up, but now the control plane cannot control the worker node independently. So now the bootstrap machine will control it temporarily. And once the control plane and all the worker node is coming up, then the bootstrap machine will hand over the control to the actual control master. And then the bootstrap machine now will be removed from the cluster, because it has done its function. It has injected all the resources into the required machines, and it can be, so depending on the installation method, if you are using the full stack automation method, installer will automatically remove it. If you are going with the second method, that is we are doing manually, that case we have to manually remove that machine from the cluster. So this is what installation bootstrapping process. So you can see that in the 8 points over here. Just I can go through that. If you need doubt, you can ask me. And then the last one is customizing the Openshift installation. So Openshift installer allows very little customization, because installer will take care of almost all the customization. So almost all the things. So we have a little room for us to do the customization. What are the major things you can do is, like, you can define the storage class for the dynamic storage. So later on we'll see about that. So that you can customize it. You can customize some CRs, like custom resources. The cluster, you can say, like operator resources, you can customize it. You can add some new operators to the cluster during the installation itself, and you can define some new mission sets. The mission sets are something like a template in the cloud providers. So you can define the mission sets using them different mission sets. You can able to create different worker nodes with a different hardware specification. So you can do that. So the mission sets are defined when you do the cloud provisioning, like in the AWS or some other cloud providers. So there you can have the concept of mission sets. You can define that mission sets. So you have the customization option. So there you can define what is your mission set is. Through that mission set, you can able to deploy the application. These are some of the customization options available. So with that, we are done with the installation. So we cannot have a full justification to this installation because installation is a very detailed process. But we have seen how the installation are there. What are the two major methods available? We have seen the comparison between the two methods, and we have seen about how the installation process begins. So we have just seen that here. Following this, there is a quiz. So since it is doesn't involve any hands-on, so just as a simple quiz here. In the quiz, you can see which of the following installation method requires the Openshift installer to configure the control worker node. Both the methods the Openshift installer has to configure, whether in the full stack automation as well as in the pre-existing infrastructure. The Openshift installer has to configure both the things. And which of the following installation method allows setting up the nodes using Red Hat Enterprise Linux? So it is only in the pre-existing infrastructure we have the option. So in this one we don't have that option. So only in the pre-existing infrastructure we have this option of using the RHEL more than RHEL 7.6. So we have that option. So it is going to be pre-existing infrastructure. So I have did those two things. Just go through, give a reading of this section, then you can try to answer other remaining things. There is a solution at the back also. You can go through the solution here. So with that, we're done with the first section. The second chapter. So we have done the first section, which is about the installation method. We have done that section. So now we'll go to the next section, which is troubleshooting the Openshift.
Sorry, the pre-existing infrastructure. இது வந்து நம்ம VM workstationல நம்ம இந்த ஆர்க்கிடெக்சர் கிரியேட் பண்ணலாமா இந்த ஸ்ட்ரக்சர் பண்ணலாம் தானே
VM
workstationல
VMware இல்ல என்ன மாதிரி
VMware workstationல இந்த pre-existing infrastructure இருக்குல்ல இதை நம்ம கிரியேட் பண்ணலாமா இம்ப்ளிமென்ட் பண்ணலாமா
பண்ண முடியும். ஸோ
இப்போ அந்த கோட் வாய்ஸ் வந்து நம்ம அது ஓபன் சோர்ஸா இல்ல நம்ம அது எங்க இருந்து எடுத்துக்கலாம் ஏதாவது சொல்லுங்க அதை பத்தி.
கோர் வாய்ஸ் நீங்க டவுன்லோட் பண்ணிக்கலாம், நார்மல் வாய்ஸ் மாதிரி தான்.
ஓகே, அது ஒரு ஓபன் சோர்ஸ் வாய்ஸ் தானா? ஓகே.
அது நீங்க டவுன்லோட் பண்ண அவசியம் இல்லை. நீங்க ஆக்சுவலா வந்துட்டு அந்த ஓப்பன்ஷிஃப்ட் இன்ஸ்டாலர் நீங்க யூஸ் பண்ணீங்கனாலே அதுவே ஆட்டோமேட்டிக்கா இன்ஸ்டால் பண்ணிடும். பட் நீங்க நார்மல் வாய்ஸ் மாதிரி இதை டவுன்லோட் பண்ணி யூஸ் பண்ணிக்கலாம்.
Abdul, so another one thing, so you told right 3 master nodes are required for bare metal, right? So is it only for bare metal or AWS also?
All the things are set.
So actually earlier I tried to install in AWS, but it automatically installed with 1 master server and 2 work nodes, not for 3 master servers.
What is the version you installed in?
It's 4 plus only.
But now I think maybe the newer one you have to install like minimum that is required, like minimum 3 masters and so otherwise you can
anyway master node can act as a work node, right? Worker node, right? So in that case, why do we need 3 master nodes here?
No, that is as per the standard, like enterprise standard they want to have. The master node itself can act as a worker node also, but the production wise you cannot give the workload to the master, so
yeah,
the worker node should be separated.
Okay, so yeah, I agree on that. Okay.
So that is a standard, like, but the option is you can have that, but when it comes to the production level standard, the workload should be distributed. So master node should not take care of the worker node. So in case something goes wrong in there, so the master will be down or something happens. So for that reason, for high availability, we go for 3 master nodes and 2 worker nodes. That is a standard. So, but if you have if you can, but in the lab you can see we in our own lab, lab which we are going to use, there also we have 3 masters only. We don't have worker node. The 3 masters itself will act as a worker node. So like that also, like that deployment also you can go for the 3 nodes acting as a worker node as well as a master node, but that will not be suitable for the production side.
Okay, so in production side, so we have to maintain 3 master nodes. If we need to add another thing, then that will be only for worker node, right? So at least we require minimum 3 master nodes. That's what you are referring.
Hello. Hello.
Am I audible?
Yeah. Yeah. What are you telling?
No, so what I'm doing, so in production environment, Red Hat recommend to maintain 3 master nodes, and if we need more than that, so we can increase that master node, right?
Yeah, we can increase it. There are procedures to add the node. We can increase it. So actually, you have a file called install config.yaml. So this is the using this file you can able to define the masters. Like here you can see the replicas. There you can define how many. Like default it will be 3. Like you can change this one. So
yeah, yes, I know. I saw. But by default it's 3 only. Yeah. But unfortunately I forget that one. Okay.
yeah, default at 3. Maybe you can reduce it 1. But if you are using for the personal use, you can go for 1. But for the default, it will be 3. For the production case, it will be 3.
Okay.
I think they have changed, like starting from 4.2, I think 4.2 or 4.5. That is the pre-requirement should be 3. Like.
Okay. Thank you.
Okay. Yeah. Now we'll go to the one troubleshooting bunch of clusters. Just give me 2 minutes. I'll be back. 1 minute, 2 minutes. I'll be back. We'll start now. Sorry, I got a small call in between. So we'll go to the next section, which is troubleshooting OpenShift cluster and applications. Starting from this section, we are going to see the hands-on things. So we will start with the lab. So we'll see how to work around with this lab. So you can start. So I'll just tell you how to work with the lab. So later on, when you're doing the hands-on practice, that time you can see how to use the lab. Just I'll show you a hint how to start with the lab. So to start the lab, I'll go back to this one, introduction. So here it is, orientation to the classroom environment. So I'll come back to this. Here the classroom environment, this is the classroom environment. So we have virtualized instances or cloud instances. So so this is the lab environment. So whatever you're seeing here, this dotted rectangles, so these are the master nodes, and these are the nodes, these are the support or you can say networking nodes. So this everything will be there as a virtual instances. So this machines, almost you can see 3, 4, 6 and 7 machines. So what we will do is we will log into this workstation, and from the workstation we'll be logging into the cluster. We'll do the function. So because here using these 3 masters, so you are not seeing the worker here. So what they did is to save some resources, this master machine will itself act as a worker machine. So in the real time, the worker node will be separate, the master will be separate. Since it's our practice environment, so what they did is the master machine itself will act as a worker node. It will do the dual function. So we'll have these 3 different masters. This forms the cluster. So this is an initial pre-installed OpenShift cluster. Cluster is already installed over here. So we are going to work on the production ready cluster. So we need not install it. So we have just understood the different methods of installation. Here we'll start with the directly how to configure the OpenShift cluster. So what are the different options are there? So when the OpenShift cluster is established for the first time, so how it will be like a day 3 or day 4 operation. And so this is a network arrangement. So this is how it is connected. These machines are connected at the back in this network fashion. So the utility machine, so here I'm going to, this workstation will act like a kind of a jump server. So in the real-time environment, what you will do is you will go to your VPN server of your organization. From there you will actually access your environment. So to just emulate that, so here we have the workstation. So from the workstation we'll be logging into the this cluster. So this workstation will act like a jump server. So all the work which we are going to do, so this workstation will be like a graphical server. So here they are given about the workstation. So here this course, the main computer system used for hands-on learning activities is the workstation. So we'll be into the workstation and we'll be logging into the workstation using a student user. The password for the student user will be student itself. So can note down. So we'll be logging a student user. The password for the student user will be student itself. In the rare case, the no exercise in this course logs you required to log in as a root. But if you need to do something as a root, you can use the root password as Red Hat. So there will be no requirement to do anything as a root. So you can do everything as a student user. So if you want to do, you can just do that as a root user. You can do it as using the Red Hat password. Okay. So the classroom environment like this. So below you can find a description of each mission. So what is the function of each mission? What is the IP address? What is the role of this mission? So you can find out about that mission details here. So intermediate. So main thing to note, what are the missions forming the cluster and from which mission I'm accessing it. All other missions are just for the networking purpose. So here we have one network, student network. So this is connected by a utility machine. So this machine will connect these 2 networks to it, like acting like a router device. And here we have a classroom network. So the classroom network, the classroom virtual machine, this will get the internet connection because we need to get to some registries to get the images. So we need to have internet access. So for the internet access is provided through this classroom virtual machine, and the classroom virtual machine is connected to the workstation through this Bastion or Bastion machine. So this is just you need to understand the background networking. So we're not going to do anything over here. So our job will be just we will log into the workstation. From there we will log into the cluster, and we will concentrate more on how to operate the cluster. So here just it's a background things we have at this. So this is how networking. In the real time it may be different. Like real time you will be using the normal internet connection to get over to the jump server. From there you will log into the cluster of your organization. So wherever they have hosted the cluster, whether it is on the cloud or where. So that will be different scenario. But here in the lab scenario it is like this. It's offline installation. So offline they have installed it on bare metal. So we are accessing that cluster. Okay. So how to start this lab? So here you can find in the main class dashboard, you will find a tab called labs. You can click this labs tab. There you can find something like if you look into the name, you can find create option. If you click this create, it will create the lab like this. The lab will be created. So once the lab is created, you will find these missions. What are the missions we have discussed? You can see that missions here, the master 1, master 2, utility workstation, all these missions will be created. Take some time, like 5 to 10 minutes will take some time. So once it is created, so what initially you will do is you will go to the workstation. You will click this workstation. The open console will be there. Once you click this open console, it will open the workstation machine in a different tabs. So you have to you see that you are not disabled any pop-ups. So if you are disabled any pop-ups, this will not open. So you see that the pop-ups are enabled, and here you can page mission. So once you are creating it, so you will see that the status will be like different states you will see. Once you start creating, you will see the building state. Then you will see the after sometimes you will see the active state. So when you stop this lab, you will see the stopped state. So here you will see the status of the mission, whether it is running or active. So once you are going to start the lab, see that all the missions are in active state because it is networked in some fashion. So some missions are not active. If you are saying that masters are active, but the utility is not active, in that case we cannot access the master because utility is when you look at the networking, the utility is intermediate to this. So if utility is not active, so if from the workstation I cannot reach this because I need a utility to there. So see that every mission is in active state. So by default it will be an active state. So but make sure that it is an active state so that you're able to access it. And individually you can control these missions, and there will be no necessity to get into any one of these missions. So you can do so. You can go to the master mission directly. Click this open console. It will open the master mission directly. But no need. There will be no requirement to go directly into the master mission. So you can do a direct login to the master mission, but master mission will be of minimal interface. So only the workstation will have a graphical interface, but master and all the missions will be only having the minimal interface. So there will be no requirement to get into the missions directly. Only what we'll do is we'll go to the workstation. From the workstation we will log into the cluster and we'll do all the functions. So there will be no requirement to direct. And about the lab, here on the bottom you will find something like auto stop timer. So you can see this is showing 6 hours. So once you start the lab, it will be like 10 hours. Then it will count down itself in the reverse direction. So it will be start reducing. I can increase the hours. I can increase the hours I want. I can increase to 12 hours. So for example, I am in the last hours, so I have few minutes left over here to auto stop itself. So in that case I can increase it. So I can just when I just click this plus symbol for one time, it will add 1 hour to it. Maximum I can add up to 12 hours. So by this way you can extend the lab working. So because since the lab is hosted on the cloud, so to conserve the cloud resource, they have set this auto stop timer. So nevertheless, if you set the auto stop timer, it is going to like reduce in the reverse direction. So you should make sure that so it's not auto stopping itself by itself, so that you will keep a watch on that, keep on increasing that time. And So this is about the auto stop time. Okay, so we'll go to this is about the lab. So lab is very easy. You can create the lab. Then you can log in as student user. Like I'll show you the login. So we'll log in as student user. So here, once you are opening that console, you will see two users. One is student, other is DevOps. So you will log in as student user. The password will be student itself. Everything will be in small. So password will be student. So you log in as student user. So once you log in, you will see the main page. The graphical main page of the. You will see like a blue screen, but it is not any error. It's just because that screensaver is blue. So here you can see on the top left side activities. You can click this activities, and then you can go to this terminal. So you can see the terminal over here. You can click this terminal. Once you click this terminal, the terminal will be open. So I have just changed the color, so you can customize this terminal color to be normally default it will open in black color, so you can change that using the preference. You can change the color to the terminals. So you will be opening the terminal. So once you open the terminal, so then you can log in into the cluster. So you can start working out over there. Okay. The first thing, so once you are into the lab, the first thing you have to do is you have to log in into the cluster. So I need to log in into the cluster. So once you are into the lab, so once you are at a student the workstation, so what we have to do is we have to log in into the cluster. Now let me take a picture of this. Okay. So this is our lab environment. So I have logged in as student user into the workstation. Then what I have to do is I have to, through this network, so already this is connected through the network, so I have to do a login into the cluster. So how I am going to do a login to the cluster? So cluster login can be done by, so to interact with the cluster on this workstation machine, I need something called client package. I need the OC. So remember that workstation is not a part of Openshift. Workstation is something like a jump server. It is like a outside of the Openshift, which is, we call this as a client machine. So we need to have this client package. We call this OC command line tool. So in real time, you can download this tool from the internet. You can just go and search for OC CLI package. You can get this binary from the internet. You can download this on any machine, and you can extract that tool and add it to the bin directory. You will have this OC command line tool. Using this tool, you will have to, so any machine, whenever you want to interact with the cluster, so that should have this OC tool, that OC command line. You can see OC client. We shortly call this OC client. So this client package should be there on the machine from which you are going to interact with the cluster. So I should have this machine. I should have on this the workstation. So make sure that, so you can easily download that from the internet. So this machine already got this OC command line tool. So this is shortly called Openshift client. So shortly called as OC. So this helps you to interact with the cluster. So I have this tool on this one. And next requirement. So first requirement, I have to have that tool available on my from the machine from which I am going to interact with the cluster. I have this tool on my workstation. The next thing, to log into the cluster, I need to have the credential information. So I need to have initially I'll be logging in as a user called kubeadmin. So I'll be logging in as a user called kubeadmin user. So kubeadmin user is a fully authorized user. It's like similar to a root user in a server. So initially, when you have installed any OS, any Linux OS, you will have a root user. So root user is a fully authorized, and later on you will create the regular users and you will manage permission and all these things. Similar to that, in the OpenShift cluster, so initially to access the cluster as fully authorized user, like a root user, so we have a user called kubeadmin. So kubeadmin is a fully authorized user. Using this user, I can fully authorize, like I can do anything I want to do in the cluster. So like I can do the full administration function of the cluster. And initially I'll be logging as this user, and then I have to use the kubeadmin password. So when you want to do a login, three things are essentially required. So as which user, username. So you need to have a username, you need to have the password of that user, and you need to have the API URL. So that we are logging into the cluster API. So we call that master API URL. So I need to have that URL. So because it is going to, when you're logging in, so it's going to search for that URL. So I need to have that master API URL. So these are the three essential things are required to log into the cluster. And this one is only first time. So when you're doing it from the machine, for the first time you require this URL. So once you access that URL, this URL information will be stored as a fingerprint in my machine. The next time I'm going to leave a login, I do not require to mention this again. So only one time, first time you are going to log in, that time you mention it. After that, this is optional. So next time it is optional. First time it is mandatory. Next time it will be optional. But every time the username and password is mandatory. And where I can find the username and password. So if you have done the installation, the initial kubeadmin password will be stored in the installation log. So you can go to the installation log and you can find that username and password. And now we didn't do the installation. So for the purpose of what I need to do a login, so they have stored this information in a file in one location in an offline way. From that location I can retrieve that file. In that file you'll find the password and the essential information. Using that I can log in into the cluster. So the file you can find in this location. So this is not a standard one, but this is for the lab purpose. They have stored in this location, ocp4.config. So in this file they have stored the information about the cluster login details, the pass, the API URL, the domains. So essentially I required the kubeadmin. So this is the username, I know the kubeadmin. This is a kubeadmin password, and this is the URL. So this you can see this API master API URL. I required this URL to log in into the cluster. So now I'm going to do a login. So I can do OC login. So this is the base command. So login. So here I can do interactive login. Like if I type, if I give enter now, it is going to ask for my server URL. I can provide this server URL over here. From here I can provide this URL. Then it will ask for my username. I accept the connection. It will ask for my username. I can provide the username here. Then once you provide the username, it's going to ask for the password. Once you provide the password, it can directly take you to the it will log in into the cluster. So this is the interactive login. Another login is like a non-interactive login, where I will mention all the required details in one single command, and this is not encouraged in the production. So non-interactive login is not encouraged. Only interactive logins are, because in the interactive login, when you type the password, you will not know what password you are typing. But the non-interactive login, when you do that, so you will be typing the password in the command line itself. So anybody who's having access to your command line, or anybody have a chance to see your history, they can find what is the password. That is not encouraged in the real time, but I can do it in the lab environment, because I need to know what password I am typing. So in case I want to do a troubleshooting, so I need to know whether I'm doing any mistake in the password. So to know that, I'm sure. So initial stage we will go for this method, but production side, the interactive login is always in. So this is a non-interactive login, where I'm going to mention everything in one single command. So OC login, I'm going to mention the username, which is kubeadmin. So then the password. The password is given in this file. So I'm getting this information. In real time, it will get this information from the installation log. Once the installation is completed, this password for this kubeadmin will be auto-generated, so that you can find that in the installation log. I can retrieve this password from there. So I'm entering this password from here. Then I have to mention the URL. So this information is required. I have to mention the URL from here. So now it's going to, since it is HTTPS, the certificate which it is the issuing to the client, this certificate is insecure, like because it is self-signed certificate, it cannot be verified, so that I get insecure warning. So I can accept it. This is lab environment, I can accept this one. And now you can see the login is successful. Now you can see you have access to some projects. The login is successful. You can see the welcome message. So I have now logged into the cluster. But there is no no impact on my local system. So if I do, for example, if I just clear the screen, so do you see any impact, like any change in whether I am into the cluster or not? I'm not seeing any changes over there. Just only this message has given me that I have logged into the cluster. So at any point of time, so we are not going to log in all the time and check it. So how to verify whether I am into the cluster or not through this terminal? To verify that through the command line, this tool will be very useful. Like we will be using something called OC who am I. So normally we use who am I command to know which user we are logged into the server. So here OC who am I am using to check as which user I am logged into the cluster. So if it is showing the username, they are showing cube:admin. So even though I have given here cube:admin was one single word, but here since it's a system generated, it will be showing as a cube:admin. So that's fine. So here it's showing the username. So if it is showing the username, I have logged into the cluster. So if I logged out, so if I do a OC log out of the cluster, so now I logged out of the cluster, and when I execute this command, so what it shows is it show you an error. So if it is showing some kind of an error like this, that means I have not logged into the cluster. So if you're seeing the error, you are not logged into the cluster. So this OC OMI command tool will be useful for us to detect whether we have logged into the cluster or not, whether we are into the cluster or not. So this will help us to know, because I don't have any clue on my terminal. If I just clear screen it, I don't have any clue whether I have logged into the cluster or not. So by time and now, so we should see whether we are into the cluster or not. So maybe I do some work, I get to something and get back and see. So I'm doing some operation, but later on I come to find out that I'm not into the cluster. So it's better always to check before starting any work from the remote machine. It's always better to check whether you have logged into the cluster or not. So using this OCOMI tool, so once you logged into the cluster, then once you run this OCOMI, so it will show you the username as which user you have logged in. So that username will be shown to you. So if it is showing that username, that means you have logged into the cluster. If it is not showing the username, instead of that it's showing the error, that means you have not logged into the cluster. So you are not into the cluster. So that is what we infer from this OCOMI tool. So this is the initial thing, how to log in into the cluster. So now we'll go to the chapter. So this chapter is about troubleshooting common issues with the Openshift cluster. So first thing is verify the health of the Openshift nodes. So we are going to learn some commands, initial commands. So how you verify the health of the nodes. So first command is once you have logged in. For this to start, we have to log in. So I have logged in now. So after logging in, so how to verify the health of the Openshift nodes. So Openshift nodes, so as of our lab environment, we have 3 different nodes that you can find. We have 3 different nodes, only master 1, master 2, master 3. So this node will act as a master as well as the worker. So here on the description itself you can find. So this nodes will act as a master as well as the worker. So the control plane as well as the compute plane. You can see the master 1. So here you can see compute plane as well as the control plane as well as the compute plane. So this 3 will act like that. In the real time, worker will be separate. So 3 masters will be separate, worker will be separate. But to preserve some resource, so they have followed this style. So just we want to learn some concepts. So that will not be a hindrance to learn the concepts. So it will be better. It will be okay that we have the master nodes acting as a worker node. Now, how to check the health of these nodes? This is the first thing we want to do. So verifying the Openshift nodes, the first command is OC get nodes command. So this command displays the status of each node. If the node is not ready, so if it is seeing the not ready status, that means the node is not into the cluster, it has some issues. So you have to troubleshoot that. it cannot communicate with the cluster, or it is effectively dead to the cluster. So if you are seeing the message not ready, so just I can use, after logging into the cluster, after verifying that I am into the cluster using the OC for my command, so I can just do OC get nodes. So here you can see the node here, so you can see the status. So if it is ready, means that is connected to the cluster. But if you're not seeing if you're seeing not ready status, that means it is disconnected from the cluster. So here you can see the role. So it is acting as a master as well as the worker, and you can see the time since it's up, and you can see the version. This version indicates the version of the Kubernetes. So version 1.18. so this is a version of the Kubernetes that's used here. So it is the version displays the Kubernetes version. And next is top command. So OC ADM represents administration command. So top command, this displays the current CPU and memory usage of each node. Okay. So this is what the OC ADM top command I can use here. So OC ADM top node. So this is going to list you the nodes with a different CPU utilization, like what is the CPU currently using. So it is displayed in core value. Then this percentage of utilization. Similarly, the memory in bytes. Then the percentage of utilization. So you can see that, get that information. So which node is currently utilizing more resource. And then we have something called describe command. So this will give me idea about the node, the individual node capability. So I can find the capacity of the node, I can find the allocatable capacity, I can find the allocated resources, what is there. So I can see the current condition of the nodes. All these things I can get it from this describe node command. So describe node command will give me a list of things about the particular node, a detailed description of the node. So for example, I have 3 nodes, so master and master. I want to detailedly know about master 1. So for example, what is the OS installed on the master 1? What are the current applications running on the master 1, from which project it is running? So I want to know this information. So what is the current CPU utilization? What is the allocatable capacity? What is the current capacity? All these things in a detailed way, if I want to know, I use the describe command. So I can use OC describe node. So I can follow this with the master, the name of the node, master 1. Any node you can describe. So I'm following the master 1. Here I'm going to give here more symbol, so that I'm going to give here more, so that it's going to just display me line by line. So here you can see this starts with master 1. So the name of the roles, labels, a lot of things you can see here. So you can see the conditions. You can see the conditions. Then below that you can see the system information. You can see the allocatable things. So what is the CPU, memory? What is the capacity of that node? So what is the allocatable capacity? So what is the system information? So what is the OS installed over there? So what is the operating system? What is the architecture? So all these things you can see, can get a lot of information. So what are the applications running on that node, and which project is running? So later on see about that. So you can see that information using that command. So this command will be very useful. OC describe node. So this more I'm adding just to limit that description. So this is the actual command, OC describe node. So you can describe any node to get the detailed information about that node. And next is reviewing the cluster version resources. So here first thing, you can log into the cluster. So using the kubeadmin password, we already did the login. So after logging in, so I want to get the cluster version information. So I want to use, like, what is the Openshift cluster. So we are dealing with version 4.5. So you can see that version by using this command, OC get cluster version. So this command will show you, so what is the version of the cluster which is currently we are dealing with. So this version is 4.5.4. This is the version of the cluster, and this is available for us to work now. So progressing, this represents the update process. So if it is updating, you will see this true. If it is normally it is not updating, you will see the false. And the since date, the uptime, and finally you can see the cluster status. So the cluster version, the current status. So you will see the change when there is some update process going on. You will see the status changes over here. This is what a cluster version command just to see the cluster version. And OC describe cluster version command will give you a detailed information about the cluster. So we have different channels and all these things. For example, if I do OC describe cluster version, so when you do OC describe cluster version, so this will give you a detailed description about the cluster version. You can see what are the updates available. So you can see this is now this cluster is eligible for this updates, these versions. So you can see that information. And what is this channel of subscription? So later on we'll see about different channels like stable, fast, like that. We have different channels. What is the channel of what is the channel they have subscribed to? What is the cluster ID? So each cluster will be unique. So what is the cluster ID? So you will see that cluster ID information. And these are the updates updates option available. So these are some information. You can just get this detailed description about this one, about the cluster version. And next thing is about cluster operators. So we have learned about cluster operators. So how to view the cluster operators? So the command is to use the OC get cluster operators. So this will show me the cluster operators available. So OC get cluster operators. So this will list me what are the operators available in the cluster. You can see these are the operators. These are the cluster level operators. So as I told, the cluster operators are mainly used for managing the cluster level functionalities, like cluster level the cluster level functions. So for example, you can take authentication. So this is the authentication operator. So this is available. So this is not updating. So this is progressing is false. So in case this application get degraded, you will see the degraded message. So it will automatically it will get that from degraded to the normal state. So if in case it is going degraded, so normally it will be false. So in case the operator is degrading, it will get back that operator to the normal state. Okay, so this is how you can view the cluster operators. And this chapter is completely about using different commands. So later on, as you are going to work on more with Openshift, you will learn. You will just be familiarized with the different commands. Just now we are learning. We'll just as starting stage. We are just understanding different how to use different commands. And now we come to something called displaying the logs of the Openshift nodes. So logs, in the sense, some cases to do the troubleshooting, I need to have logs related to some services. So these logs are like the journal CTL informations. The journal CTL informations will be useful for me to troubleshoot some services or troubleshoot some physical conditions on the node. Since I am accessing as per our lab scenario, so always you have to remember that we are accessing in this fashion. So we are not going directly into the machine, we are accessing from here. So this is my jump server, which is workstation. From there I am actually accessing it. So I want to fetch the information. For example, I want to fetch the information, the physical information about the master node. So I want to do some troubleshooting with that. So what I can do is I can get into the master node and get that information. So instead of that getting into that machine, if I have logged into the cluster, I can directly get that information about any node, or I can directly fetch the journal CTL information. So this will be useful for doing some kind of physical troubleshooting. And later on we'll see that we'll be using some sophisticated tools like logging and metrics tools like Grafana, Prometheus. So like that we have a sophisticated tools to provide us a very good logging and metrics information. So now let me get into this, so see how to use it. So I am into the cluster. From this I'm going to get some information from the cluster. So here I'm going to use OC node logs, EDM node logs. So whenever you use some like ADM, this represents like administration command. So like only the cluster level administrator can use this command. So this is a privileged command. So we see ADM node logs. And so I'm going to mention the node name. So master 1. So once I mention that node name, so you will see the journal informations, journal serial informations of that node. So you can see I'm getting this information from the workstation. I'm into the workstation. I'm not logging into physically in that machine, but I'm able to fetch this information using that specialized command. So that you get through this information, you can able to do some kind of troubleshooting, physical level, service level troubleshooting, in case the machine is not properly up or properly not working. So this produces me a lot of results. So I just cancel it. Just if I want to specifically get some information about some service, because this gives me a lot of standard results. So I don't want to go and I know some service is specifically wrong. So in that case, I can just use -u option. And service user, I can mention the service user, I can find out. For example, I want to know about the SSHD service, about that. So you can see the status of that service, where it stopped or started or something like that. So you can see that information about that particular service. So this will be give me just information just related to some particular service. So instead of going through all the logs, so I can have a information just about the particular service. For example, if I have if I want to know whether the web server is running, web server service is running over here or not, I can just get that information. The web server is not running over here, so I don't have any entries for the web server. So by this way, you can just like you can jot down like whatever the information you want. So specifically, you can get that information by just mentioning that service. So if you don't mention that, you will get the specific information. And next is opening a shell prompt on the Openshift node. So how do you open a shell prompt? So what does it means, the shell prompt, opening a shell prompt on the Openshift node? So it means like taking a remote. So that's what the opening a shell prompt. So I'm accessing the master node in a remote fashion. Just I want to get into the master node and I want to do some actions on the master node. So normally when we want to take a remote, so we have option. So like when I want to take a remote of a system, so for example, this is master 1 and this is workstation. Consider this is a machine. So this is a workstation. So when I want to take a remote of this, so to check some information or to do some modification, so I want to take a remote of this master. So what normally we'll do is we have two options. One is to use a telnet protocol to get to this, or you can use a secure protocol like SSH. So there are two options too. Either you can use telnet or you can use SSH to get a remote. So this is the option which is available to take a remote of this. Conventional way we have this option, but these options are not recommended in the Openshift. So if you want to take a direct remote of this, so these two options are not encouraged, even though SSH is very secure, but this option is also not encouraged in the Openshift environment. So if I want to take a remote, so what is the other option I do have? I do have. So since the master machine is having the core OS, so I can do something called a debug pod. So a temporary debug pod will be created. So through this debug pod, I can take a remote of this master. So this is a new concept which we are learning. So the debug pod. So debug pod is a temporary pod which will be temporarily created. So when I want to access the machine, I will be accessing by getting through the pod. So, but I have to have a proper permission to create this pod. So I should be a kube admin. So then only I can create this debug pod. So through this debug pod, I can access this master. So that means normally I'm taking a remote of the master. So how to do that? So because you can do the telnet and you can do the SSH, that will work fine. but this is not encouraged. It's not a best practice to use it, since for example the SSH is a secure protocol, but there are some vulnerability even in the SSH protocol, like the port number is standard, so everybody knows through the port number 22, so that is standard. So we have to change the port number to make it more secure. And the session you're opening to the telnet is session you're opening to the SSH is like you have a strong timings, like you have to adjust some timing. So unless if you don't forget to adjust the timing, so that's why the terminal session may be opened for a long time. So through that session, somebody can hijack the session and they can able to get into the mission. So it's not encouraged as from the security perspective. So they always encourage to use something called a debug pod. So debug pod. So here I have 3 nodes. So I can get into any one of the node from here by creating a debug pod. To create a debug pod, the command is OC debug, then the node slash name of the node. So here I want to get into the master 1. So here you can see now the starting pod to master 1 debug. So this is a pod name. So this pod is started. So now it will be straight away getting the root shell, and I have to run this command to change the to the host shell. So I'll run this command to change the host shell. Now I can check something on this. So now actually I'm into the master node itself. So I can check, for example, I can check the OS of that master. So I can do OS release. I can check the OS of that master. You can see this is Red Hat Enterprise Linux Core OS, and you can see check the some services. System CTL is active. You can check some services. So for example, I want to check the service kubelet. You can see this service is active. So like that you can do anything you want into the cluster. So this is like almost a remote shell, but we are doing it a different way. So we are creating something called a debug pod. Through this debug pod we access, because it is a secure way of this. And this core OS will allow me to create that debug pod. It'll help me to interact with that node through the debug pod. Normal OS we cannot able to do that, but the core OS we can able to create a debug pod, and through that I'm able to interact with that node. So if I exit out of this, so if I'm exiting out of this pod, so if I do a exit, you can see that the debug pod is removed. So there will be no trace, like no port information or no logs will be generated. There will be no connectivity information. So it will be like very clean. Like whenever I require, I just get into that, create a debug pod. Through that I access it. Then I come out of that pod. It is almost removed. So this is a secured way of doing that. So even though you can use the SSH will work. So nothing is going to prevent you from doing, but it's not encouraged to use a SSH or telnet protocol to take a debug. So this is what opening the prompt, opening shell prompt from the Openshift node using the debug command. So one warning is that when you are using the debug command is that so you should exercise care, because the OC debug node command, some action can render your Openshift that nodes become inaccessible. For example, if you stop the kubelet service, you cannot recover using the OC command. So because it will stop responding. The kubelet service is actually one which is going to help me to communicate between the API server and the worker node. So if the kubelet service is stopped, I cannot access that node becomes inaccessible. Then I have to physically get into the node by some means, and then I have to start that service. So I cannot use that again communicate back through the debug command. So if I don't have any SSH credentials, I cannot communicate. So the communication stops. So I should exercise care when I am doing the when I'm using the debug command. Okay, so next is troubleshooting the container engine. So from here we are going to start with like application deployment. So we are going to see how to deploy the application. So how to create project, how to deploy the application. So we are going to see that. Then we'll see the troubleshooting issues and troubleshooting commands. So okay, now I think almost time for lunch now. So almost now it's 1:30. So we'll continue this one after the lunch. So By 2:30 we'll take 1 hour for lunch. By 2:30 we'll start this session, because if I start it now it will take another half an hour or 40 minutes, so it will be like past 2. So now we'll stop up to here, then we'll start the next session by 2:30. So there we'll study about how to deploy the application. So far we have learned about the cluster level things, how to check the cluster level things, how to log into the remote machines, and how to check the logs, and how to log into the cluster, how to verify the nodes of the cluster, verify the health of the cluster. All these things we have seen. After that, now next is to see the application deployment. So how to deploy the application, how to do that, how to start the troubleshooting. We'll start that. So we'll start after the lunch. So we'll start back by 2:30. Okay.
Abdul, so in my workstation it's showing right missing or incomplete configuration info when I enter OC command.
Sorry, what you are getting?
I'm getting missing or incomplete configuration info.
On which command?
OC command, OC who am I? All the OC command, when I enter any OC command, it's showing like that.
Okay, you have logged into the cluster?
No, I can't able to log in. No.
You can log in, right?
No, I can't.
Okay. You can log in like you can retrieve this file, right?
No, there is no such file here.
Yeah. For this file, actually, you have to run one one lab setup command. So that will generate it actually. So you can see on page number 36. When you run this command, like lab execute troubleshoot, you run this command on the workstation. So this will generate this this location will generate that configuration file. So once it's generating, then there you will find the keyboard and password number. Using that you can log in. So this you have to run this lab setup command to get this one. But if you're not running this lab setup command, this file will not be available. So to see this file is there, run this lab setup command, or you can wait until you're going to start doing the lab.
Sure.
Once I completed it, then you can start doing the lab by here. That time you can run it, then you can start working here.
Abdul, Mohan here. Actually, while logging in, you are giving username and password, and there is an HTTP link you are giving it, right? What is it? And why you are giving that?
This URL you are asking.
URL, yeah.
This is the server. Like so, I talked about the architecture. We are interacting with the API server. So this is the server which we are logging in, and whatever the things we are doing, we are getting into the server. Then we are authenticating the server actually. So after authenticating the server, then whatever the request we are giving, so it is going to this server actually. So that is a server. That is a server master API URL. So this is the API URL. So we are logging into that. So we are just doing the command line. So we need to log in, we need to authenticate it. So we need to mention that URL, because I'm doing a login. So where I'm logging, so the question itself, like where I'm logging. So I need to log in into some kind of a server or some kind of a machine, something. Okay. So here we are logging to the API server, so that I can provide that.
In this case, actually, we are having 3 master nodes, right? So in any one of it will be logged in, or else, because in each master node it will be having an API server, right? Am I right? In each master node, we will be having each API server.
So it is like a common login. So whatever we are creating, that is created inside the API server. So we not worry about in which master it is created. It's like acting as a single unit. But you can see that API server running on 3 master nodes. You can just get OC, get pods. You can see on this project, it is running over there. You can see the API server running like 3 times it is running. You can also see where it is running. So this command you can see it is running on all 3 master nodes. So master 1, master 2, master 3. But for us, only one URL. So this is for high availability. It's going to load balance internally. So we need not worry about in which master we need to log in like that. So it's learning on all 3 masters. So for high availability, it is there. So we need to, as a user, I just need to log into the API server. So I need to worry about where it is running. So internally, it will do the load balancing. Internally, it will see currently which master is going to take the load. So that will be taken care inside internally.
Okay, thank you.
Okay, so yeah, we'll start back by 2:30 p.m. for lunch.